Okay, let's continue. This one is natural log of 1 over e. Now, if you remember your basic exponent rules that I started off the first lesson with on Monday, that involved us moving the exponents up or down and changing the signs from positive exponents to negative exponents. So let's look at this one. Natural log of 1 over e. This e right here is raised to the first power. If I want to move this e to the first power to the top, I can do that, but that means that I have to change that first power to a negative 1. Okay, so now we're able to apply one of the properties of natural logs. Now remember what I said about natural logs. It has a base of e. So there is an understood e right here. Even though you don't see it, there is an understood e. Now, what did we say about this understood e and this e raised to a certain power? It's as if the e here and the understood e here cancel out, leaving you with just the exponent, which happens to be negative 1. So that is my answer, negative 1. Okay, let's try another one. Natural log of e squared. And we have, again, we're going to apply the same kind of property for natural logs. If you think about it, look at your function. It's a natural log function. And it is an understood e right here. Even though you don't see it, it's an understood e. Now that understood e with the e right here will cancel out with one another, leaving you with just the power as your answer, which happens to be 2. Okay, so now let's continue. We're going to use the definition of logarithms to write in logarithmic form. So this time, we're going to actually go back. So the first example, now I'm giving you an exponential. And what did I say at the beginning of this lesson? If I'm giving you an exponential function and I'm asking you to rewrite, that's understood as rewrite it into a log function. Vice versa, if I'm giving you a log function like what I just did earlier in the slides, that must, and I'm telling you to rewrite, that must mean that you're going to rewrite it into an exponential function. Okay, so let's go back. And I'm going to actually work this problem out with you. We have 4 to the x equals 16. So that is in the form a to the y equals x. So let me go ahead and get a new one. All right, so we have a to the y get a new one. I don't like the way that one's looks like. All right, a to the y equals x. And I'm using this form because that is the form my actual problem is. It's in the form 4 to the x equals 16. Okay, so we have 4 to the x equals 16. 4 to the x equals 16. And we want to write it into the logarithmic form, which is log of base a of x is equal to y. Exactly as it states in our first slide. Y equals log of x base a. Okay, very simple. Let's match up each letter. So here the A represents the number 4. Here the Y represents X. And here X represents 16. Okay, so let's rewrite it into a logarithmic function. So I'm going to have the log of base A. Let's look at our A and see what it represents. It represents the number 4. So base 4. Let's look at what X represents. X represents 16. Very good. So we have log of 16 base 4 equals Y. Let's see what Y represents. It represents X. So if I'm rewriting in logarithmic form, it's log of base 16 base 4 equals X, which, as you can see, is the correct solution. Log of 16 base 4 equals X. Okay, let's go ahead and do another one. E squared equals X. E squared equals X. Now, one thing, whenever you see the E, you automatically want to connect it to natural log. You're going to have to start getting in that habit. Every time you see an E, you're going to have to start connecting it with natural logs. And anything else, it'll be a regular logarithmic function. Okay, so again, E is natural log. So we have E squared equals X. So let's rewrite that. All right, so we have E squared equals X. Now again, that is in the form A to the Y equals X, which, if we want to rewrite it into natural log, that'll be natural log of base A of X. Let me erase this. Equals Y. Okay, natural log of X base A is equal to Y. So let's go ahead and match up each of these letters. Here we go. A will represent my E, Y will represent my 2, and X will still represent my X. So if I want to rewrite this as a log function, it will be ln, very good, ln, base A. Well, here our A is E. Now that makes perfect sense because we know that natural logs, when we're discussing natural logs, they are always in the base of E. And then we have X, well, X is still X, equals, and then we have Y. And in this case, Y equals 2. Okay, now we can rewrite this as a little bit more formal. We don't necessarily have to write that E because we know that all natural logs have an understood base of E. So we can just say that natural log of X is equal to 2. Both of these solutions are equivalent and I will accept them. I will accept both of those solutions. So let's check. And that's exactly what we got. Natural log of X is equal to 2. Okay, let's discuss the graph of a natural log function. It says graph and find the domain of the following functions. We have y equals natural log of x. Okay, so now what I want you to do is you're going to go ahead and, this is probably a calculator exercise. So let's go ahead and open those calculators up. And let me go ahead and actually open my calculator in this section. Let's see if I can find it, unless I deleted it from this computer. It's right here. Now remember, if you look at your calculator, the natural log button is the button that's right next to the number 4. It says LN. Alright, so we have y equals natural log of x, and we are going to take we're going to make an x and y table. It's nothing new. We've done this before in the previous section, and we're going to basically fill out each of those values. So let's look at the natural log of -2. Type that in, and what do you get? Let's try it. Natural log of -2. So I'm going to have natural log -2, close my parentheses, and I get an error. Okay? So maybe we can just put error. Go ahead and put error. And it says error, non-real answer. So just go ahead and put error. Now let's try type in natural log of -1. And let's see what happens. We get the same thing. So we get an error. All right, no biggie. Let's go ahead and try natural log of 0. All right, so we have natural log of 0. And we get another error. But this time it says domain. Still no biggie, so we're going to write error. Now, let's go ahead and take the natural log of 1. Let's see if we can get a value for that one. Okay, the natural log of 1. Yep, we start getting values with the natural log of 1. Very good. So it's kind of safe to say that we cannot take the natural log. Now remember what I said about natural logs. When I'm discussing natural logs, I'm also meaning regular logs, logarithmic functions. So natural log and logs, as you've noticed in their properties, share the exact same characteristics. So it's safe to say that we cannot take the natural log of a negative number or 0. Very important. You cannot take the natural log of a negative number or 0. Okay, we've done the natural log of 1 and we got 0. If you type in the natural log of 2, you get 0.693. If you type in the natural log of 3, you get 1.098. If you type in the natural log of 4, you get 1.386. And again, double check my values and see if you get the same thing, or at least practice inputting each of those values in there. And if we type in the natural log of 0.5, notice that it's a 0.5, not a 5. The natural log of 0.5 gives me -0.693. This is a very important function. This is really the natural log parent function that you should be familiar with how it looks like. Alright, so now essentially you can graph the x and y points. Here in this case we're obviously going to start with 1 and we're going to graph the rest of them, and we get a curve that looks like that. And the question in the slide says graph and find the domain of the following functions. Okay, now the domain is the x-axis. Now, if you take a look at the x-axis right here going horizontally, look at your curve. Does it go past the origin? It does not go past the origin, which makes sense in your table because it cannot be negative numbers. Past the origin towards the left-hand side are negative numbers, and it doesn't follow that. And that makes perfect sense with your table. Now, the next question is, does it touch 0?